If you came across this video, you're probably searching for a project how to stream audio through your Raspberry Pi using a DAC module, and maybe a title has caught your attention mentioning digital signal processing. Yes, you can say another DAC project, but hold on, this one is a little bit different, because this project will bring you through insights of digital signal processing with interaction through the software, where a user can apply different filters, change the tabs of the filters, mask them with different windows, change the upsampling factor, change the cutoff frequency, and also you can enhance the gain of different bands. Everything will go through when I present the software. But now let me walk you through the hardware first. So we can see on the stack audio source. The signal is pre-processed with preamplifier, where then is fed to Hifiberry DAC2 ADC PRO module. So input is ADC, then Raspberry Pi computes and processes the signal, and output, the output is fed to DAC, and from DAC we are amplifying the sound, the signal, to speakers so we can hear it. This project is a reflection of my study of computer and electronic engineering degree at Atlantic University of Sligo, and one of the modules was digital signal processing, and I really enjoyed that, so I applied the knowledge and came up with idea how we can interact with audio via software. Now let me hop on the screen and I walk you through the insights of the software. Okay, back at the computer, let me walk you through the software side of it. And the project is stored on GitHub. A repo is shared by link down below, and at the top we have a short description of the project, table of contents, project overview featuring bullet points, and installation setup is next, where you can clone the project repo and by cd to it create the virtual environment for isolation from kernel, and then install the necessary requirements are listed below here. For hardware side of it, description is here how to connect your modules. When you choose option 1, connecting module PCM510 to a DAC and sound card via USB, which your source of audio is processed, and then once DSP is done, the digital to analog converter sends the signal to your amplifiers, and modules can be found here. Your software setup or hardware devices drivers can be found here, and you set up overlays for your PCM 502, create or edit your sound config file, reboot the machine and check if your sound devices are listed. Or second option, you can set up DAC module from Hifiberry. Links to the components are here, and the source of audio is coming and received via 3.5 jack socket. DSP processes the signal, and then DAC converts it to your analog, back to analog, and is sent to your amplifier. Again, device drivers are setup is here. Same for a sound config file. Reboot the machine, check your devices if they're listed again. For software architecture, these are the files. The main two are for streaming processes. One is where you set up your attributes for filters and upsampling and block size, and then you compile it. This will trigger the streaming, where the stream process with equalizer and GUI is more interactive, real time. We'll see it a little bit later. So uh, these files are offering use of low pass, high pass, band pass, and band stop filters. Can be overlaid with windows, different type of windows listed as seen. We can use different methods, more options, and usage of examples. And here we have a method where the filter is created, and we parse these parameters via main streaming script, and by adjusting these values we can get a different audio response. And these are the bash commands for the processing scripts. For visual side of it, the first stream process script is plotting us filter we have designed and its phase representation, and also impulse response, which is nicely centered. The second script, a little bit real-time intuitive script, the GUI side is here, and in here we can change around all the settings. Once the changes are applied by pressing apply setting, the audio will be adjusted as we show it a little bit later. And this is a quick example about plotting the filter. And some troubleshooting steps, if you struggle, might not include all of them. There could be always different issue if you come across one, but it should be solid, bulletproof. And the last section, before last section, acknowledgement, just references to links used for this project. And now we're gonna see some real-time DSP filtering. So I have already loaded the script through a Tony compiler, and as I'm playing on audio, I don't want to keep it too long to be caught by writes, but let's crank it up for a couple seconds. And just for a quick presentation, I can change up to 4 max upsampling, and we can see the audio. We can hear the audio has a little got a little bit richer, and we can change tabs to, let's go a bit extreme, 501. Keep the tabs odd number, just to have a filter nicely balanced. And if we choose a show spectrum, we can see the spectrum, frequency spectrums responding to filter cutoff frequency. We can change the cutoff frequency, let's say to 10,000. And okay, ideal would be at sampling 1 factor, and this is nicely seen. We can just quickly apply some, let's say, tile window, and we see how filter has changed.
And also, like I was saying, you can adjust a gain for different frequency band and play around. So I welcome you, and I wish you're gonna have a lot of fun changing and examining and listening to your favorite music and trying to achieve as best sound as possible. Of course, this project is not finished and has more to work with. I'd love to improve a little bit implementation of changes. There's a still short break, and we can see I'm profiling the code to see where we are losing the most of the time, and the main audio callback is a little bit long, so I'd like to improve that because we're still getting message of input overflow and output underflow, and also could be done. The GUI could be expanded for more plots. So yeah, this project can be enhanced and can be expanded. So stay tuned, and I'll be working on it in the future. Maybe some extra features, but as far as now, this is nicely working and offers you experience to apply the real-time digital signal processing procedures. Uh, Feel free to study or examine the code. It's uh, it's as minimalistic as possible because there's a lot of going on. So go through the methods one by one, and hopefully it's gonna make all sense. The main audio callback is where the most of the DSP is happening. So there are comments. You can do a bit of research to each comment if you like to know more about each process. As I said, I had the opportunity to study these concepts, so I can see through them. But enjoy and good luck then.